Okay, note down the another problem, that is determine the impulse response for the cascade of two linear time invariant systems having impulse responses h1 of n is equal to 1 by 2 whole power n u of n and h2 of n is equal to 1 by 4 whole power n u of n. Okay, this is the problem. So to solve this here, so firstly understand the problem, that is, so they given two impulse responses. Okay, those are in cascading nature, like this. This is h1 of n, LTI system response, impulse response, and this is h2 of n, LTI system impulse response. These two are connected in series way, cascade way. So here if input is applied, output is y of n, right? So here they asked determine the impulse response of this cascading of two LTI systems. You know that from the convolution property already we have the discussion on this. If two systems are in cascade nature, this is nothing but convolution of these two impulse responses, may be considered as a single system. Now here x of n is input, y of n is the output. Both are having the same output. Okay, that's why. So if all the systems are in cascaded, just to find the impulse response, just to find the convolution of all individual impulse responses and then take as a single system impulse response, like this. So now we have to find out this system impulse response, let it be h of n. So h of n, what is this h of n? h1 of n convolved with h2 of n. Okay, so now just take here h of n is equal to, what is the h1 of n? 1 by 2 whole power n u of n. What is the h2 of n? One by 4 whole power n u of n. So these two are convolved. Okay, right? So that's why here take the convolution definition. Now apply here. What is the convolution definition? Summation y of n is nothing but x of n convolved with h of n. In such a case, that is x of k, h of n minus k, where k is minus infinity to infinity. This is x of n convolved with h of n. You know this definition. Okay, so now here we need h of n, that is h1 of n convolved with h2 of n. So the formula is summation k minus infinity to infinity h1 of k, h2 of n minus k. Okay, in this way we have to write the definition, right, from this basic definition. So take the first sequence as it is and then use the dummy variable k, and then take the second sequence here with the replacing of n minus k to this n, right, then use this formula. So now here h of n is equal to, from this equation, summation 1 by 2 whole power, h1 of n is this one, h2 of n is this one. So it is h1 of k, 1 by 2 whole power k, u of k. What is the h2 of n minus k? 1 by 4 whole power n minus k, u of n minus k, right. So here k minus infinity to infinity. So now this is summation k 0 to infinity 1 by 2 whole power k, 1 by 4 whole power n, 1 by 4 whole power minus k, u of n minus k, since u of k is equal to 1 for k greater than or equal to 0, 0 for k less than 0. So now this one is also equal to h of n. Okay, so here 1 by 4 whole power n is there, so take it outside, then summation k 0 to infinity, then 1 by 2 power k, 1 by 4 power minus k, 1 by 2 power k, that means 2 power minus k, 1 by 4 power minus k, that is 4 inverse whole power minus k. Am I correct? 1 by 2, 2 power minus 1, 2 power minus k, 4 inverse power minus k into u of n minus k. So here you know that u of n minus k, already discussed in the previous problem, 1 for k less than or equal to n, 0 for k greater than n. So from this, right, so here it depends on the n range. So case 1 is n greater than or equal to 0, case 2 is n less than 0. N greater than or equal to 0 means k range is from minus infinity to n. Here also k range is minus infinity to n. Okay, right, in both cases. But here k range is from 0 to infinity only here. That's why. So now k is from 0 to n. So instead of this one, place 0. Instead of this one also, place 0. So 0 to n, here n is less than 0. Here n is less than 0 means, right, so k limits here actually less than 0. So in the case 2, this h of n is equal to 0 in this case 2. So now coming to the case 1. So case 1 discussed in the previous video. So see for this elaborate explanation. Okay, case 1. So now n greater than or equal to 0. So range of k is 0 to n. Now h of n is equal to 1 by 4 whole power n summation k 0 to n. Here 2 power minus k, that means 2 into, here also 4 power minus 1 whole power minus k. Okay, now this is equal to 1 by 4 whole power n summation summation 2 by 4 is 1 by 2, that means 2 power minus 1. Am I correct? This one, 2 power minus 1 power minus k, that is 1 by 4 whole power n summation 2 power k, k 0 to n. Now this is equal to, so okay, here see 2 1 by 4 2, which gives 1 by 2 means 2 power minus 1 in such a way. So we are writing, okay, right. Then so h of n is equal to, what is that, 1 by 4 whole power n from the formula. This is nothing but, okay, right, what is that, 1 minus 2 power n plus 1 by 1 minus 2. Good. So now here the formula is summation a power n n0 to n minus 1 gives the 1 minus a power n by 1 minus a. This one also discussed in the previous video. 1 by 4 whole power n, 1 minus 2 power n into 2 by minus 1. So 1 by 4 whole power n, here 2 power n into 2 minus 1. This is nothing but 4 power minus n. Four power minus n or 1 by 4 whole power n. So now here common 2 power n. Now here it is 2 minus 1 by 2 power n. Now 1 by 4 into 2 whole power n, 2 minus 1 by 2 whole power n. Here 2. So now this is equal to h of n is equal to 1 by 2 whole power n, 2 minus 1 by 2 whole power n. This one is under the condition n greater than or equal to 0, right? For n less than 0, h of n is 0. That's why this is here. Here is this one. So now combinedly this h of n is rewritten like this: 1 by 2 power n, 2 minus 1 by 2 power n u of n. This is the impulse response of the cascading of two systems. Okay, and then homework problem is, do the homework. So asked in here 2018 regular DSP paper. The question is, determine the convolution of the following sequences that is following sequences: x of n 2 power n u of n and h of n 1 by 2 whole power n u of n. And do this problem, you will know one, and then okay, solve this. We will discuss the answer in the next class. Okay, thank you.